Okay, so today we are going to be looking at solving radical inequalities. So during class we solved radical equations, but now we're going to be looking at inequalities, and there is a little bit of a different step we have to add into this situation. So first, we need to think about when we're talking about only the real number system, so not complex numbers, but just real numbers, what must be true about the radicand when taking the square root? And what I mean by that is what has to be true about what's inside here. Remember, that's the radicand. So when I'm taking the square root, what has to be true? It must be positive. So if you said it must be positive, then that is correct. It must be positive. When I'm taking the square root, it must be positive. So here I have a few examples where we're going to look at what must x be in these following expressions. So if I'm telling you that under the radicand has to be positive, then I'm going to set it greater than or equal to 0. Okay, so if in this first one's done for you, but the second one, if I have the square root of 5x minus 8, and I say that the radicand must be positive, then it needs to be greater than or equal to 0. So if I do 5x minus 8 is greater than or equal to 0, I would add 8 to both sides, and I would have 5x is greater than or equal to 8, and then I would divide by 5. So x is greater than or equal to 8/5. Okay, then for this next one, 3x plus 9 has to be greater than 0. So 3x plus 9 has to be greater than or equal to 0. So I would subtract 9 and have 3x is greater than or equal to negative 9. And then divide by 3. So x is greater than or equal to negative 3. So once again, this is just practicing making the radicands positive or greater than or equal to 0. So that'll be part of what we're doing as we're solving these inequalities. So when solving inequalities, we have to solve two parts. First, we have to solve the actual inequality. So our first step is to solve the inequality. Then our next step is going to be to solve for the radicand to be greater than or equal to 0. So just solve for whatever's inside the radical to be greater than or equal to 0. Those are our two pieces that we're going to have to do. There's two parts, so I even have broken the notes down into step 1 and step 2. So looking at this next set of example problems, first thing I need to do is solve the inequality. So I'm going to square both sides to get rid of the radical. And then once I do that, I have 2x plus 4 is less than or equal to 16. Okay, then I subtract 4 from both sides and have 2x is less than or equal to 12 and divide by 2. So x is less than or equal to 6. That's part 1. Okay, it's just solving the inequality, the problem. Okay, then I have to go in and make sure the radicand is greater than or equal to 0. So I have 2x plus 4 is greater than or equal to 0. It will always be greater than or equal to 0 at that point. Sorry, that got ahead of me. It will always be greater than or equal to 0, right there. Okay, so then I'm going to continue solving. So 2x is greater than or equal to negative 4, and x is greater than or equal to negative 2. Okay, so I've solved my two pieces. Then I'm going to draw a number line. So see on this number line, I put negative 2 and 6, and x has to be greater than negative 2, and x has to be less than 6. So my solution is from negative 2 to 6. And I have brackets because I have greater than or equal to and less than or equal to. So I have the equal to sign. Okay, so first I had step 1, and I solved the inequality and got x is less than 6. Step 2 is the part where I take the radical and make it greater than or equal to 0. It will always be greater than or equal to 0. I solved that and got x is greater than or equal to negative 2. I put that on a number line and found my solution. So let's do another one. Let's do the one below that, which is also kind of similar. So first thing I'm going to do is take the actual inequality, 8x plus 1 is greater than or equal to 7, and I'm going to square both sides, and I get 8x plus 1 is greater than or equal to 49. Subtract 1, so 8x is greater than or equal to 48. X is greater than or equal to 6. Okay, so that's the first side. Okay, then I'm going to take the radicand, 8x plus 1, and make it greater than or equal to 0. It's always going to be greater than or equal to 0. So 8x is greater than or equal to negative 1. If I divide both sides by 8, I get x is greater than or equal to negative 1/8. Okay, so I'm going to put that on a number line. I have negative 1/8 and I have 6. Okay, so it's greater than 1/8, it's greater than 6. Where's the only place that both of those overlap? So my solution is 6 to infinity, or x is greater than or equal to 6. Either one of those solutions would work, because if it's greater than 6, it's automatically greater than negative 1/8. Okay? Let's try another problem. So this next one, we're going to do the one at the top. Before I can square both sides, what do I need to do? Okay, hopefully you said subtract 2. So I have the square root of x minus 3, and I have that less than or equal to 3. Now I can square both sides. Okay, then I get x minus 3 is less than or equal to 9. So x is less than or equal to 12. Okay, so that's the first part. So I subtracted the 2, I squared both sides, and I solved for x. Okay, now I'm going to take x minus 3 and make that greater than or equal to 0. Remember, it's always whatever is in the radical greater than or equal to 0 every time. So x is greater than or equal to 3. So let's graph this one. So I have a 3 and a 12. So I want to be greater than 3 and less than 12. So where do they overlap? Between 3 and 12. Okay? Last problem. So I'm going to subtract 9 first. So x, I'm going to go ahead and just write it right here, minus 9 minus 9. X minus 7 is less than 3. Square both sides. X minus 7 is less than 9. X is less than 16 when I add 7 to both sides. Okay, then I take the x minus 7 greater than or equal to 0. Remember, once again, it's always whatever's in the radical greater than or equal to 0 every time. So x is greater than or equal to 7. So on a number line, I'm not sure you're going to be able to see that one. Let's see. Let me try it right over here. Okay, I have 7 and I have 16. Okay, I want to be greater than 7 and I want to be less than 16. However, why is 16 an open circle? Hopefully you saw that right here it's not equal to, it's just less than. So it's an open circle. So my solution this time is 7 to 16. 7 has a bracket, 16 has a parenthesis because it was an open circle. Okay, so once again, all of these have two parts, the inequality and then the radicand. Okay, let's look at this last question. So this is just kind of a plug and chug answer. So in order to compete in the America's Cup sailboat race, a boat must satisfy this rule. Okay, where L is the length in meters, S is the area in square meters of the sails, and D is the volume water displaced by the boat. Okay, so if a boat has a length of 20, I'm going to replace this with 20, displaces 27 cubic meters of water, so I'm going to replace D with 27. We want to find S. Okay, so I have 20 plus 1.25 square root of S minus 9.8 cube root of 27 is less than or equal to 16. Okay, so I'm going to simplify one thing for you. What is the cube root of 27? 3. So I have 20 plus 1.25 square root of s minus 9.8 times 3 is less than or equal to 16. Okay, so what I want you to do is I want you to finish this problem, and we will talk about it at the beginning of class tomorrow. So it's kind of a little bit of just to see if you knew it if you were watching the video, and see if you can try that problem, and we will discuss it at the beginning of class tomorrow. See if you can simplify it. If not, I'll answer those questions when we come to class. So I hope everyone has a great evening, and I will see you all in class.